Okay, so yeah, should be live here. Yeah, so that's streaming. All right, guys. So let's go back to that app now. All right. Everybody seeing it?
Yes, sir.
All right.
Yes, sir.
All right, good. So the concept that we have been learning couple weeks before Easter was the atomic structure. And for CXC, this is a model here. These you see an X in the middle and you see some blue dotted line circles, right? So let's start with this X in the middle. What do you think this X, which part of the atom is represented here by the X? All right. And
Sir, the nucleus, sir.
very good, O'Neill. Very good. And yeah, you've been doing well. And you should get your I don't forget your prize. You still don't get it yet. Well, I guess I have it in memory anyway. I wrote it down somewhere, so don't worry yourself. But yeah, you're doing well. Seeing a lot of quite a few of you guys were doing well last term. But so I see. I hope that the standard can continue. But here is the nucleus of the atom. All right, guys. I hope everybody remember what is found in the nucleus. All right. What particles can we find in the nucleus of an atom? All right, that's a question. What particles are found in the nucleus of the atom? All right, so nobody knows that.
Sir,
Sir,
protons.
Okay, hold on. All right, hold on. Somebody was saying something before you, O'Neill. Who was that?
Me,
Tiana?
sir.
Yes, Tiana, go ahead.
So I was saying if it was proton.
You're saying if it's protons. All right. All right. Everybody agree with protons? Protons in there? Is protons in the nucleus? You agree with that, O'Neill?
yes, sir.
Okay. Chris and Tia there as well. Kamai. Khadija. Right. Need to be hearing from you guys. And
Was talking to me, sir.
oh, so whoa, if I was talking to you, I was talking to everybody and nobody is responding. So that's how it is. Then you come back. Everybody, and then I have to take, I'm tired to tell you guys, you have to take control of our class. You have to be involved and participate. You can't be a silent person here. All right. Know that if this was a party or something like big entertainment, you guys would be involved in it. So why can't be involved in the class? So just like how some of you can dance good and shake up good and all that sort of stuff. I mean, you guys can learn good as well. They can learn well and you can perform. So same attitude. So expect everybody to be involved. All right, guys. So yeah, O'Neill said that this X is the part where the nucleus of the atom is, and I went on to ask what particles are found inside the nucleus. Tiana responded by saying that protons are in there. O'Neill is saying yes, protons are in there. But are there any other particles in there in the nucleus of the atom?
The neutrons, sir.
Okay, O'Neill is saying neutrons. All right. So some persons not saying anything because perhaps they don't have a clue. But what am I to do? I'd have to just continue. All right. So protons and neutrons are in the nucleus. The nucleus represented by X, center of the atom, guys. So when we're drawing the atom, that's where we start. We start from the center. All right. Now, this activity is building an atom. So you see, a more real life way to do it. Now, notice that when I put one of these protons in the atom, what what you see happens in the middle? What you see come up in the middle?
Hydrogen.
Sir, hydrogen.
All right. No, hydrogen is there. So, all right. If I were to remove it now, you realize that what? There's no more hydrogen, right?
Yes, sir.
Yes,
Yeah.
sir.
All right. So let's talk about the structure of the atom now. The middle of the atom is made up of protons and neutrons, right? And there's something else. What do those blue circles, dotted line circles mean? All right. And anybody else apart from O'Neill and Tiana can answer this one. What do the blue circles mean? What are found on the blue circles and what are they called?
Sir, the blue circles are called shell and electrons are found.
Okay, Kristen, live and direct. Good to hear from you. Yeah, all right. Very good, Christian. I hope everybody heard that. The blue dotted lines are actually called shells, and there are actually two other words for shells. All right. What are the two other words we can that mean the same thing as shells in an atom? Nobody know that? There are synonyms for the word shells.
Sir, is it electron shell, sir? And
No, that's not that. It's same. That's the same word. That's the same word, Tiana. I want a synonym. Different word that mean the same thing.
Proton shell, sir.
No, don't make up words. I didn't teach you those words. I remember mentioning it to you, and it's even on the screen. But it means that when you learn things, you learn piece a piece, and you try to understand the thing properly. All right. So we say shells is one word for it, but we don't see shells on the screen, but we see another word that means the same thing as shells. All right.
Sir,
So you
orbit, sir.
orbits, yeah, long time is there. So you guys know, I don't know how to learn, but you have to learn, be alert and focus because see orbits there on the screen. So the word orbit is right here. So shells, this will write down that. Shells means the same thing as orbits or orbitals. Everybody get that?
Yes, sir.
yes, sir.
All right. So shells, another word for shells is
Yes.
orbitals. Britannia, dear. Yeah. All right. So, all right, guys. So now there is another word that means the same thing as shells and orbitals. All right. Now, if you didn't know this word, then that's okay because maybe this word is above your level. But I'm gonna put it on the screen so that and I'm gonna call it. So when you go back to the board, you'll see that on the board. Another name for shells or orbitals is actually energy levels. All right, energy levels. All right, so energy levels now means that the further you go away from the nucleus of the atom is the more energy anything found on those shells have. All right, everybody heard that?
Yes, sir.
Yes,
All right,
sir.
now let's confirm with this question. What we said are found on these shells are orbitals. What particles are found there?
Electrons.
All right, very good. Electrons are found there. So, all right, guys. So that means that we have all of these three particles covered. So protons, neutrons, and electrons. All right. So I'm gonna send the link for this app. You can actually practice with this. So this app that I'm using is available to everybody. and I'm gonna send this link to you guys so you can practice using it. All right. You guys gonna have another lab coming up, and that lab will be done online. All right. But this is just a start here, guys. Atomic structure here. In the middle, we have protons. So we'll add one proton, we see hydrogen. All right. Let's see what happens. We add two protons. What that change to?
Sir, helium.
Right. So seeing that we had a third. If we add a third proton, what will it change to?
Lithium, sir.
All right, lithium. All right. So that is it. That's pretty much it. All right. Elements are named based on the number of protons they have. All right. Let's try something here. Let's reset this, and let's close that, and let's try something else. What if we try to use electrons? Notice that we see any element name come up?
No, sir.
No, because that is not how elements are formed. Elements are formed based on the protons. All right, elements are named and numbered based on the protons. So on the periodic table, we see these elements. We say H, we say He over here. Then next row, we say Li, and we say Be. All right, and it goes across. Any questions here, guys?
No, sir.
No, sir.
All right, good. So elements are named based on protons. All right, so now notice that when you put in one proton, not only does the word hydrogen come up, but something else comes up. All right, what other word is it come up? What other word in red you see come up, guys?
Sir, Ian, or what's your Ian.
Ian?
If I pronounce right, sir.
You say Ian. Oh, guy, make it sound like the name of a boy or a guy. All right. Well, no. You good try though. It's actually not pronounced as Ian, but anybody can pronounce it a different way.
Iron, sir.
Very good, O'Neill. Yeah. All right. Somebody else was here answering it, saying iron is the right pronunciation. So it's iron, guys, right? Iron. That's a word that you guys need to learn in today's class. What is an ion? All right. So an ion is pretty much an atom that has more electrons or less electrons than it's supposed to have. Everybody understand?
Yes, sir.
Let me repeat that again. An ion is simply an atom that has more electrons or less electrons than it's supposed to have. All right. So let me show you something now. This hydrogen is an ion because it has no electrons. But how can we change this into an atom? All right. The rule for the atom says that the number of protons are equal to what? The number of what? Number of protons should be equal to what?
Electron, sir.
Very good. Electrons. So for those of you who missed out a lot of class last year or couldn't bother to go up on YouTube and watch a video of them, this is things that you're supposed to know. Number of protons is equal to the number of electrons, guys, in the atom. All right. Number of protons equal number of electrons. So now this hydrogen here has one proton, but then there's no electron on these shells. And then so in that case, this hydrogen is an ion. All right. So the argument are when you're learning chemistry, it is important to know the difference between an atom and an ion. All right. So so an atom is neutral. Right? An atom is neutral because what? Because the proton number or the number of protons is equal to the number of electrons. All right. Now, hope everybody is remembering all of this, because I'm very annoyed when people forget things that they're supposed to know, especially when it's up for the world to see. The world is seeing all of what you guys doing. So you know, you guys are not alone. So you guys better pull up on the socks. Serious time we're doing in chemistry, serious stuff happening. All right. So the atom is neutral because the proton number is equal to the number of electrons. All right. And not only that, anybody remember the charge that the proton has? But what word we use to describe the charge that a proton have? Nobody knows that? All right, what is that? All right, let me ask you something then. Anybody know what the word charge mean?
Sir,
Like
the way they react, sir.
the way they react. All right, that's a good way to look at it. Anybody else? Anybody with something different?
Sir, charge means they have to do it like energy or electric.
Energy electric. No,
Electricity.
you're going technical no man. You're going deep. Before you can go deep, you have to lay the foundation first. So I think you're onto something there, Tiana, but not exactly where I wanted to go right now. O'Neill, let's look at what you said, which is you're saying that it's the way how it reacts. So yeah, protons, as you can see, and I want to show you something here. If I take up the proton, all right, what color you see? What is the color of this proton on the screen? What color it look like to you?
Sir, orange.
Orange. All right, fine. And what color is this with the electron?
Sir, blue or sir can have a purplish color to it, sir, but blue, mostly blue, sir.
All right, so fine. So basically, in this little app that we're using, they are showing you that the color is character. Color blue. All right, it's supposed to be blue and red, but then if you know anything about blue and red, right? In terms of color, anybody near the art? No, nobody does art. All right, well, just understand, say blue and red are on opposite sides of color scale. All right, them oppose each other on the color scale. They're on opposite sides, guys. All right, so almost like if you go to most schools now who who usually have sports day, it come in like every school have like a blue house and a red house, right? Everybody have experience being in a blue house or being in a red house yet?
Yes, sir.
Yes, Abigail. All right. So same thing now. Now, people that are in the red house on sports day shouldn't go over to people who are in the blue house on sports day. All right. Well, anybody ever experienced where them tell you say if you go over to another person's house, then your house lose points? You never hear that yet? All right.
Yes, sir.
Yeah. All right. The point is here that, and let me just take it off here. So the point is that the protons behave differently from electrons. Right? Protons behave differently from electrons. The word charge means how it behaves, how it attracts other things around it. That's basically what a charge is, how it attracts other things around it. Now, let me show you this then. If so like for example, Tiana, let us say the police will catch you having party and then them say you have too much people in the party and them hold the whole on and say them are go charge on, right? what would happen to you when you get charged?
Sir, you either would get a ticket, sir, to pay your money.
Mm-hmm. But you end up getting to pay something. So you have to give something. So, all right. So that's pretty much it. Our proton now has a positive charge because, well, let's put it this way, it tends to push things. All right. So it basically is have a pushing force. And so you mentioned something about electricity, Tiana. Yeah, electricity has two forces, a push force and a pull force. So if you notice, if you should hold a wire that has electricity, all right, what would happen to your body?
Sir, I can get shocked, sir.
Yeah, but what happens when you get shocked?
So your body
Your body do what?
jerks.
Your body shake and jerk, all right? All those things happen because what? There's a pushing force and a pulling force, right? In electricity, there is a positive charge and there's a negative charge, right? Positive is pushing, negative is pulling. Everybody see that?
Yes, sir.
All right, I hope you understand that. So positive is this, right? If you look on the screen, I'm pushing towards you. That's positive because I'm giving you something, all right? But then if I am the person who likes to steal now, I'll take something. So that's what? Negative. Everybody understand that?
Yes, sir.
All right. So we have positive charge and we have negative charge. In an atom, they are balanced out. So there's no charge. So what is happening here is that this has one proton, but doesn't have any electron to balance it. Protons are positively charged. These are the pushers. And of course, the electrons now have the opposite charge, which is negative. So they are the pullers. So one push and one pull. So one push and one pull, and you notice that it maintains the shape there. So that's why the atom has this shape where the protons stay away from the electrons, but there's an attraction between them. So for every proton, there is an electron. All
So,
right.
sir.
Yes, go ahead, O'Neill.
Sir, but sir, you said that protons is equal to the number of electrons.
Right.
Sir, basically they are the same, sir. But how come they are the same and have different charge, sir?
All right. So because the rule with it with life, and with this in chemistry is that opposite charges attract each other. All right. So if you understand that, O'Neill, you are a boy, right? And Tiana and a few other girls in the class are girls, right? You might be attracted to one of them. What if they were males? Would you be attracted to them?
No, sir.
All right. So it's the same thing these protons and electrons are saying. All right. Protons are attracted to electrons. Electrons are attracted to protons. You understand that now, O'Neill?
Yes, sir.
All right. So now you put a proton in an atom, but didn't put an electron in there. This proton will be lonely. All right. And we know how lonely people can get. Lonely people are what? Desperate for company. So what we're learning in chemistry is that whenever we have things called ions, another name for ion is actually a radical. Radical means say what? If anybody know the meaning of the word radical?
Sir, like get upset, sir.
All right. If you look at it, at it that way, yeah. Although it means more than just being upset, though, it actually means aggressive. Right? You aggressively go after something. And so when ions are in nature, when ions are because ions can be forming, guys, atoms can lose their electrons, based on what they are experiencing, based on what we as humans do to them. So, for example, when we get the gas from IGL or Gas Pro or Petcom, right? The gas is there minding its own business, have all the electrons it wants, and everything is okay. Then now we decide, say, with the hungry belly self, say, we want some food. So what we do now? We'll go into the kitchen and what we do now? We strike our matches for those of you who have them type of stove there. And we turn on the gas. And what happens when we strike the match and put it against the stove after turning on the gas?
Sir, then the stove we light, sir.
Yes, it ignites. And you say, what is the name of the thing that you see? Start with F.
Fire.
Yeah, that's fire.
Sir.
And what causes fire?
Sir, gas and heat.
Well, gas and heat. Well, you would say that if you are first and second farmer, but you're in fourth farm, no. So it actually goes back to what I'm saying. These little blue things here, where you see, this is what causes fire, you know. This thing here, electrons cause fire. All right, because if I go and ask you this question, and I taught you this last year, all right, what is the fourth state of matter? All right, so we have solid, liquid, and gas. Which is the other? Which is the fourth one? Class?
Sir, plasma.
Oh, Chrisanti is saying it. Yeah, but the internet connection is bad. Well, I hear the word come out, Chrisanti. Well done there. So it's plasma. All right. So for a moment there, I was saying that you guys didn't understand the question in English, and I would have to translate it in Spanish for you guys, but I didn't have to do that, luckily. All right. So yes. So the plasma is the fourth state of matter. That is what you create now with heat. When you bring heat towards atoms, right, the electrons move faster and they move further away. You're giving it more energy, so it moves away from the atom. All right. Remember, we said that the other name for shells is energy level. All right. So when we strike a match, it means that we're giving some heat there. Heat causes electrons to move further away from the protons. And then after a while, when they move too far away, right, the atoms change into ions. And when the electrons move at that speed, it starts to give off some of that heat energy that you gave it now converts into light energy. And so that's what causes fire. And guess what? There's so much energy there that if you with your mischievous self, decide to put your hand against that energy that forms the fire, what will happen to your hand?
So I get burned.
You get burned. Not only you get burned, but let's put it this way. Your hand also loses some electrons as well, because the heat energy transfer to the electrons that are in your hand that are stabilized by protons being equal to them. But then you give the electrons now bounce into other electrons and give those electrons more energy. And those electrons start to leave. And then next thing you know, your hand burn up. No longer you don't have a pretty skin anymore. You have an ugly skin with a burn there. And then that's what happens. All right. Any questions here, guys?
Everybody says skin struggle, look how you see. Check out fire when you're
What? So hold on, Tiana. They what I'm trying to explain to you is that fire gonna mash up your skin. So you're saying that.
Sir, for me no mash up, sir. Sir, for me, alright, sir.
So you're saying that you get burned already and your skin alright?
Sir, do we have, sir, alright. Sir, when the fire do burn me, sir. Sir, my skin, sir, look like it dark come off. Sir, and it did black. Have a purplish color, sir. Sir, but
Okay.
after, sir, I did go doctor, sir. Then they give me something to use. Then it after. So I still have a couple marks, so the fire burns. So my hand look away. So it's still at least 90%.
Okay. But the point is that when you see a mark or anything on your skin after being exposed to fire, it means that you have lost electrons. All right. That is just the story of it. And well, if you describe it as pretty or ugly or okay, then that's up to you. But the point is that you have less electrons, so your body now has to well get more from somewhere. And that's why you eat food, because when you eat food now, your body breaks down everything into simply more protons and more electrons. That's how you grow. All right. So chemistry is explaining how life takes place here, guys, at the simplest level. All right. So the simplest element in the universe, guys, is hydrogen. All right. Um, what would we say is the most important part of the universe? What is the most important part of the universe? All right. No, I should put it this way. Um, what part of the solar system caused us to be here in the first place? If that part of the solar system were to leave, we would die. Which part of the solar system is that? All right. No, the solar system is something you'd have learned in grade.
Excuse me, sir. Sir, can
Yes,
you
go
repeat what you said?
repeat what I said. Um, repeat what I said. You weren't you there a while ago when I was speaking?
Sir, you are breaking up, sir.
Oh, I was breaking up. Oh, hush. All right. Um, maybe your connection was breaking up. I was perfectly okay. But all right, let me go back over that again. I don't even remember what I was saying. All right. Anybody who was listening can as all right. Anyway, the point is that um let us forget it, yeah, man. All right, let me just switch back on the screen and let me show you. All right, so these are the things, and it's coming towards the end of class anyway. So let's continue, because so we have the radical here, guys. Another name for the ion is a radical. All right, we're going to talk more about that next class. And of course, we have the atom here. Its information here is that atoms are neutral because the proton number equal to the number of electrons. All right, I didn't put what an ion is. An ion is an all right, let me just start from the article here. All right, so is charged, an ion is charged because the proton number is not equal to, all right, not equal to electron number. Electron number. So that is the rule here. So guys, from today's class, you should be able to tell the difference between an atom and an ion. All right. You should also be able to tell me what other words mean the same thing as the shells of electrons. All right. These words that are put in the box here. All right. And so that those are two important information here. All right. I'm gonna see you guys on Friday, and we're gonna go through some more of this concept, because before we can move on, we have to know these things. All right. And I don't want anybody to be left behind, even though some people will be left behind for whatever reason. But just remember that you hold your destiny in your hands. So can't blame anybody say, Ray. There's always a way. I try to give you several ways to stay with class, but some of you don't, either you don't appreciate it or you can't bother, whichever way it is. But you guys will suffer if you don't pull up your socks. So here it is now, guys. I'm gonna go through the register, and all right, let me see. I'm seeing, well, we had as many as 12 persons online, and some of them drop off. So all right, we could just do this really quickly so you can go for a break. All right, 14th of the 4, 2021. Seeing Tiana. All right, seeing O'Neill. All right, Abigail, just coming on back here.
Sir, am I the only boy in the class, sir, like overall generally on the register, sir?
Yeah, that's a good question. I don't think so though. I don't think that others are coming. I think I see Andrew. No, but Andrew Stewart. I don't know if Andrew is there. And I think I remember seeing like Samuel Barnes. So I think there are about three. So you have competition, O'Neill. So you alone can get all the girl. So it have a share. All right. So O'Neill, see
What
you.
makes, sir?
You know what I mean? Nobody, you're too greedy, man. You have to, you see, you have to have other guys, man. 'Cause you have to work. You have to work hard for what you want. Let me see something. You have Kamai. All right. All right. We have Kristen. All right. I'm seeing Lori. All right. I have not seen Sharai. Anybody heard from Sharai? Is she still alive? What, Sharai Farkison? All right. So I guess nobody knows each other in the class. All right. That's cool. Are you guys antisocial? All right. All right. And we have Ruda here. I'm seeing Khadija. All right. All right. And of course, Chrisanti. All right. And I'm seeing Abigail. All right. Abigail,
Sir.
you have family in Clarendon?
No, sir.
Okay, just checking. All right. All right. I'm seeing Britannia. Britannia? All right. So anybody else don't see them name? Anybody else missing them name? All right, going once, going twice. That's who I'm seeing now. All right. All right. So you guys have any questions at this point?
No, sir.
Also,
All right, guys. So thanks for coming out today. I try to send these notes in the group as well. Well, not much notes, so maybe I might not send it until Thursday. But guys, you see, this was just to recap and refresh your brain because we're going to go hard after this. So you guys need to read up and understand atomic structure, right? From any source you can get it from, any book, any video you can watch, understand atomic structure. Come to class asking questions about it or even sharing new information about it. All right, guys. So I'm leaving it. I'm leaving your learning in your hands. All right. So you guys make the most of it. All right, guys.
sir,
Yes, go ahead, Tiana.
sir, the work for physics class, sir.
Yes,
Yeah,
yeah, I
yeah,
got it.
sir.
I got it. So I'll look at it tomorrow, marketing class, and show you what's going on. All right.
Okay, sir.
All right. Good. All right, guys. So that's it. Enjoy your break. Enjoy your rest of the